Okay, in this video, we'll take a look at section 3.4, which is solving applied problems with two equations. Now, our first objective, we're going to solve applied problems involving total value and mixture. Now, the strategy here is you're going to assign each unknown a different variable. So let your first unknown be x, let your second unknown be y. Then you're going to create a table organizing the information given to you. After that, you're going to create two equations using the table that you created. And then after that, you're going to solve the system of equations. So solving the system of equations, you could use one of the three methods that we learned previously: graphing method, substitution, elimination. I would recommend avoiding the graphing method because you really need graphing paper and a rule to make sure that it's accurate. So we'll stick with the substitution and the elimination method. Let's take a look at an example. So it says a campus bookstore sells college t-shirts. White t-shirts sell for $18.95 each, and red t-shirts sell for $19.50 each. If receipts for the sale of 30 t-shirts total $572.90, how many t-shirts of each color did the shop sell? Okay. So let's go ahead and create a table. Okay, now over here we have two categories. We have white t-shirts, we have red t-shirts. Now let's create a column for the number of t-shirts. Then our next column will be the price for each color. And then our third column, this would be the total price for the certain amount of t-shirts that were sold. Okay, so number of t-shirts times the price of each t-shirt. This has to be equal to the total price of that specific color. Now, white t-shirts, we don't know how many white t-shirts were sold. So let's go ahead and let's put that as X. That's one of our unknowns. That's what we're trying to figure out. Red t-shirts, that's another unknown. We'll let this be Y. Now, the price of white t-shirts, this was $18.95. And the price for the red t-shirts, this was $19.50. Now we can write out an expression for the total price. So the number of t-shirts times the price, this equals the total price. So for white t-shirts, we have an expression of $18.95 times X. And then for red t-shirts, we have $19.50 times Y. Now let's go ahead and create another row. We'll let this be the total. Okay, so now the total number of t-shirts sold, tells us in the problem, was 30. And then the total of those 30 t-shirts was $572.90. Okay, now we have to set up a system of equations. So taking a look at this, we know that there was 30 t-shirts sold. Okay, the number of white t-shirts and then the number of red t-shirts has to add up to 30. So we have one equation as x plus y. This has to be equal to 30. So now we have our first equation. Now we still have to write out a second equation. The second equation will come from this last column right over here. The amount of money the bookstore made from the white t-shirts plus the amount of money that they made from the red t-shirts. This has to be equal to that total amount of $572.90. And now we have our two equations. Okay, so now let's go ahead and solve this system. Now, one thing that I'm going to do over here, I'm going to keep my first equation the same. And I want to get rid of all those decimals in my second equation, just to make it a little bit easier. So I'm going to go ahead and multiply that second equation by 100. That way I can eliminate all those decimals. So I have 1895x plus 1950y. This has to be equal to 57,290. Okay, so now we're left with this equation without any decimals. Okay, now you go ahead and use the elimination method or the substitution method. Okay. I'm going to go ahead and use the elimination method in this problem. So you have to choose a variable to get rid of. I'm going to go ahead and get rid of my x's. So since the bottom equation has 1895x, I want the top equation to have negative 1895x. So I'm going to go ahead and multiply this by negative 1895. Okay, so I get negative 1895x minus 1895y. This has to be equal to, okay, so let's go ahead and multiply the last part. So 1895 times 30. Okay, this gives us 56, so it's going to give us negative. We have 56,850. Now the second equation we didn't multiply by anything. We kept it the same. Okay. And now we can go ahead and add these equations together. So adding them up, our x's cancel out. Now negative 1895y and positive 1950y. This is going to give us 55y. We have equal to. Now let's go ahead and subtract the right hand side, because there's 440. And now let's divide to get y by itself. So divide both sides by 55. We get y is equal to 8. So the number of red t-shirts sold, so this was our y variable, number of red t-shirts sold was 8. Okay. So now we could go ahead and figure out what our x is. And just like before, if we want to figure out what x is equal to, we'll go ahead and plug that into one of our equations and solve for x. So I'm going to plug in y equals 8 into x plus y equals 30. So I have x plus 8 is equal to 30. Subtract 8 from both sides. We get x is equal to 22. Okay. So now we solved our system. This tells us we have 22 white t-shirts and then 8 red t-shirts. And now we have our solution. Let's take a look at another problem. So it says the coffee counter charges $18 per pound for organic Kenyan French roast coffee and $16 per pound for Sumatran coffee. How many pounds of each type should be used in order to make a 20-pound blend that sells for $16.70? Okay. So let's go ahead and create our table. Break it up into two columns for our two unknowns. Okay, so our first column we have Kenyan French roast. Another one we have Sumatran. Okay. Now our first column, okay, we don't know how many pounds of each that we need. All we're given is that the total amount has to be 20 pounds. So our first column will put the amount of coffee. The amount. Second column will be the price. And our third column will be the total price. Okay, so the amount, we'll let our first unknown be x. Second unknown, let's let that be y. Now French roast coffee, the Kenyan French roast, this sold for $18 a pound. The Sumatran sold for $16 a pound. So the total price for here will be 18, I believe it says 18x, since we don't have any change there. Another one would be 16y. Okay, and let's let our third row, let's let this be the mixture. Okay, the final product. Now we know that our final product has to be 20 pounds. So we mix them, it has to be 20 pounds. And now the amount that they want to sell it for is $16.70. So now the total price that they're going to sell this 20 pounds for, so it'd be 20 times 16.70. This gives us 334. Now let's go ahead and create our system of equations. Okay, so since the final mixture has to be 20 pounds, that means the amount of Kenyan plus the amount of Sumatran, this has to be equal to 20. Okay, and then the second equation we get from that last column, the price for the Kenyan plus the price for the Sumatran, this has to be equal to 334. And now we have our system of equations. Okay, so once again, I'm going to go ahead and use the elimination method. Okay, so let's go ahead and get rid of our y variable. So since the bottom equation has positive 16y, I want the top to have negative 16y. So we're going to go ahead and multiply this by negative 16. The bottom equation we don't have to multiply by anything. So we have negative 16x minus 16y. This has to be equal to negative 320. Then our bottom equation we didn't change. Now let's add them together. So negative 16x and positive 18x, this gives us positive 2x. Our y's cancel out. We're left with equals 14. Go ahead, divide both sides by 2. We get x is equal to 7. So this tells us that we need 7 pounds of the Kenyan French roast coffee. Now we have to figure out how much of the Sumatran coffee that we need. So let's go ahead and plug in our x into one of our equations. So easiest one would probably be that first equation. So we're going to plug in. I'm going to plug in x equals 7 into x plus y equals 20. So we have 7 plus y equals 20. Go ahead, subtract 7 from both sides to get y by itself. We get y is equal to 13. Okay. So we have 7 pounds of Kenyan. We have 13 pounds of Sumatran. Now let's take a look at a different type of problem. Okay, this time we're going to take a look at interest problems. Now with interest problems, we have the formula principal times rate times time is equal to interest. Okay. So for this example, it says, Jasmine invested a total of $3,700 for 1 year at simple interest, yielding $297. Part of the money is invested at 7%, and the rest is invested at 9%. How much was invested at each rate? Okay. So we have two unknowns here. Let's go ahead and create our table. Okay, so the two unknowns are the two different rates that we have. Okay, one of them was 7%. The other one was 9%. Okay, so we'll have the amount. We're going to use let's use our formula. So let me use the same words. So we have principal times rate times time. This has to be equal to the interest. Okay. Now the principal, this is the amount of money that was invested. So we don't know how much money was invested in each account. So we let one of them be X, we'll let the other one be Y. Now the rate, we're given the rate for each account. So one of them is 7%. Now the only thing that you want to do here is you want to change 7% into a decimal. So this would be 0.07. 9% would be 0.09. And now the time, since it says 1 year, our time for each one would be 1. Now the interest collected just from the 7% account, we'll use this formula. So it's principal times rate times time. This is equal to the interest. So we have x times 0.07 times 1. This gives us 0.07x. And for our 9% account, this will give us 0.09y. Let's create our third row for the total amount. Now for the total amount, we're not given like a specific interest rate, so I'm just going to put the total here. Now the principal, this is the total amount of money that was invested, which was $3,700. Okay. And then the total amount of interest collected was $297. And now we could go ahead and set up our two equations. So the amount of money in the 7% account plus the amount of money in the 9% account, this has to be equal to the total amount that was invested, which was $3,700. So this gives us x plus y has to be equal to 3,700. And then our second equation has to do with the interest. The amount of interest collected from the 7% account plus the amount of interest collected from the 9% account has to be equal to the total interest that was gained, which is 297. So you have 0.07x plus 0.09y. This has to be equal to 297. And now we have our system of equations. Okay, so let's go ahead and use our elimination method again. First, I'm going to get rid of these decimals. So I'm going to multiply that by 100. So I get 7x plus 9y is equal to 29,700. And now since we're using the elimination method, okay, let's go ahead and choose a variable to get rid of. Since my bottom equation has 7x, so I'm going to get rid of my x variable. So I'm going to multiply the top by -7. That way I can get -7x. So I have -7x minus 7y. This is equal to -25,900. Now let's add the equations together. X's cancel out. -7y plus 9y gives me 2y, and I have equal to. Let's go ahead and subtract these. Okay, I get 3,800. Now let's get our y completely by itself. So let's go ahead and divide both sides by 2. We get y is equal to 1,900. Okay, so we know that there was $1,900 that was invested into the 9% account. Now we have to figure out how much was invested in the 7% account. So once again, you're going to go ahead and plug that in. Let's plug it into the first equation and figure out what x is equal to. So let's go ahead and plug into x plus y equals 3,700. So we have x plus 1,900. This has to be equal to 3,700. Now to get x by itself, go ahead and subtract 1,900 from both sides. We get x is equal to 1,800. Okay. So $1,800 invested in 7% account. And then there was $1,900 invested in 9% account. So all these problems, they're very similar to each other. You want to create your table, and then from your table you create two equations, and then you solve the system of equations. Okay, let's take a look at a different type. This time we have liquid mixture. So the liquid mixture problems, the formula for this is the amount times the strength. This has to be equal to the pure amount. So with this example, it says King's service station uses two kinds of cleaning solution containing acid and water. Attack is 2% acid and Blast is 6% acid. They want to mix the two in order to get 60 quarts of a solution that is 5% acid. How many quarts of each should be mixed? Okay. So let's go ahead and create our table. Okay, so our first unknown, we don't know how much of the TAC solution to mix, and then the other one was blast. Now let's follow that formula. So the amount times the strength, this has to be equal to the pure amount. So what that formula tells us, so the amount of the solution times its strength, this will give us like the pure amount of acid that's in the solution. Okay, so now the amount, we don't know how much of each to mix. So we're gonna let attack be X, we'll let blast be Y. Now the strength of our attack solution is 2%. So once again, we're gonna change that into a decimal, so we have 0.02. And then our blast solution is 6%, so we're gonna let that be 0.06. Now the pure amount, you go ahead and multiply the amount with the strength. So you have 0.02x, and then you have 0.06y. Now let's put a third column for our mixture. I'm sorry, a third row. Okay, now the total amount. So it says in our problem, we need 60 quarts. So the mixture has to be 60 quarts. Now the strength, this was given to us. We want the strength to be 5%. So we have 0.05. So now the pure amount of acid, so let's go ahead and multiply this out. 0.05 times 60 gives us 3. So the pure amount in our final mixture would be 3 quarts of pure acid. Now we write out our equations. So the amount of attack solution plus the amount of blast solution, this has to be equal to the total amount in our mixture, which is 60. Now the pure amount of acid in our attack solution plus the pure amount in our blast solution, this has to be equal to the pure amount of acid in our mixture. Okay, so we have our system of equations. I'm going to go ahead and get rid of our decimals. So I'm going to multiply the first equation by 100. I'm sorry, the second equation by 100. So you get 2x plus 6y is equal to 300. And now if we're using the elimination method, I'm going to go ahead and get rid of my x's. So since we have positive 2x, I'm going to multiply the first equation by negative 2. So I get negative 2x minus 2y. This is equal to negative 120. Add the equations together, x's cancel out, we're left with 4y is equal to, gives us 180. Now divide both sides by 4. We get y is equal to 45. Okay, so we have 45 quarts of our blast solution. Okay, now to find out the amount for our attack solution, we're going to plug it into the first equation. X plus y is equal to 60. Okay, so we have x plus 45 is equal to 60. Now go ahead and solve for x, so subtract 45 from both sides. We get x is equal to 15. Okay, so we have 15 quarts of attack and 45 quarts of blast. Now let's take a look at our next objective. This is going to be solving applied problems involving motion. So our motion formula, we have rate times time is equal to distance. Now our first example, this is the classic when two trains leave. So we're given a train leaves Barstow traveling east at 35 kilometers per hour. Then we're given 1 hour later, a faster train leaves Barstow, also traveling east on a parallel track at 40 kilometers per hour. How far from Barstow will the faster train catch up to the slower train? Okay. So let's go ahead, let's create our table. Okay, so we have two trains. We have a slow train and we have a fast train. And we have rate times time equals distance. Now the rate of the slower train is 35 kilometers per hour. The rate of the faster train is 40 kilometers per hour. Now our unknowns here, one of our unknowns is the time that the trains were traveling. And then the other unknown is our distance. We don't know how far they traveled. Now, if we let the time for the slower train be x, now the amount of time that the faster train was traveling, since it says 1 hour later the faster train leaves, that means that that train has been going for an hour less. So that means that the faster train would be x minus 1. And now the distance for each one, okay, since we're going to use two variables, the distance that they traveled has to be the same. Okay, so in order for the two trains to catch up with each other, that means that the two distances have to be the same. So each one is going to be y. Now let's go ahead and solve or set up our two equations. So we have rate times time equals distance. So we have 35 times x has to be equal to y. And then we have 40 times x minus 1 has to be equal to y as well. So we have our two equations. And now for this particular problem, since our y is already solved for, we already have y by itself, it might be a little bit easier to use the substitution method. So we're going to plug in y equals 35x into the other equation, 40 times x minus 1 equals y. Okay. So remember, each one of these we can rewrite it as y being first, so we can have this as y is equal to 35x, and then the second one we can rewrite this as y is equal to 40 times x minus 1. Let me go ahead and rewrite this one. So we're going to plug it into y equals 40 times x minus 1. Okay, so the y in my second equation, I'm going to replace this with 35x. So I have 35x is equal to 40 times x minus 1. Okay, now let's go ahead and solve for x. Let's distribute. So I have 35x is equal to 40x minus 40. Let's get the x's on one side. So subtract 40x from both sides. Okay, so subtract, we get negative 5x is equal to negative 40. And then let's go ahead and divide by negative 5. We get x is equal to 8. So now let's go back to the problem to see what it was asking us for. It says, how far from Barstow will the faster train catch up with the slower train? Okay. So our x, this represented the slower train. So it means that the slower train was driving for 8 hours. So since the faster train was 1 hour less, so it started traveling 1 hour after, that means that the faster train will catch up to the slower one in 7 hours. Okay. And that's all we were asked for. So we didn't have to figure out what y is equal to. Y represented the distance. Since the problem wasn't asking for the distance, we didn't have to solve for y. We just had to solve for x. Let's take a look at one last one. So now, an airplane flew for 4 hours with a 20-mile-per-hour tailwind. The return flight against the same wind took 5 hours. Find the speed of the plane in still air. Okay, so let's create our table. So we have two categories here. One is with tailwind, and then the other category is against the wind. We have rate times time equals distance. Okay. So it's asking us to find the speed of the plane in still air. So when there isn't any wind at all, we want to figure out how fast this plane goes. Now with tailwind, so if the wind is pushing against the tail of the plane, that's going to be helping your speed. So we have the speed of the plane plus 20. So let's let x be equal to the speed of plane. Now, if it's going against the same wind, this time the wind is pushing against the plane, pushing towards like the front of the plane, which is going to be hurting your speed. So the speed of the plane would be x minus 20. And now the time here is given to us. So with the tailwind, it took 4 hours. And then against the tailwind, it took 5 hours. Okay. And now our distance, the distance has to be the same here because it traveled a certain distance and then it came back that same amount of distance. So our distance here is both going to be y. Now setting up our equations. So rate times time equals distance. So we have 4 times x plus 20. This has to be equal to y. And then we have 5 times x minus 20. Also has to be equal to y. Okay. Now instead of putting rate times distance, what I did is I put time times the rate. Just so we could have our numbers on the left-hand side of the parentheses. Something that we're a little bit more used to seeing. And remember, so I'm just going to rewrite this. This is the same as y. Y is equal to 4 times x plus 20. We have y is equal to 5 times x minus 20. So once again, we could go ahead and use the substitution method. So I'm going to plug in. So since our y is already solved for, it's more convenient if we use the substitution method. So I'm going to plug in y equals 4 times x plus 20 into y equals 5 times x minus 20. So I'm going to replace this y over here with 4 times x plus 20. Okay, so we have 4 times x plus 20. This has to be equal to 5 times x minus 20. Let's go ahead and solve for x. Distribute. We have 4x plus 80. This is equal to 5x minus 100. Now let's go ahead and solve for x. Subtract for x from both sides. Let's add 100 to both sides as well. Okay, so on the left hand side, the 4x and negative 4x cancels out. 80 plus 100 gives me 180. 5x minus 4x gives me x. Negative 100 and positive 100 cancels out. And now I have my x by itself. So the speed of the plane is 180 miles per hour. So that was it for section 3.4. As always, if you have any questions, don't hesitate, just email me.